All right, so today we're going to be talking about linear quadratic systems. So before we get started in the mathy math of it, focus down here, we need to look at what our possible solutions could be. And I know it seems kind of duh, but it's still important to talk about. So there are three possible scenarios when we have a system that's got a parabola and a line. So situation number one is the one on the left. They don't touch. That's no solution. Situation number two is that this line is tangent to your curve, so you get one solution. And in situation number three, the one on the right, is this line goes through this curve and hits it in two spots. So we can have 0 solutions, 1 solution, or 2 solutions. I think that generally speaking, the first method that we're going to do is graphing. Generally speaking, it is not the smartest to do unless you've got a calculator with you. So this problem is going to work out, but they don't all work out so nicely, and then you end up estimating, and somebody might get upset with you. All right, so what I'm going to do for this one is all the stuff we did before. So I'm going to start by graphing my parabola, which means I need to find my vertex, which means I need to do the negative b over 2a to find my x component. So negative b over 2a is equal to, let's see, negative 5 over 2 times 2 is 4. So there's our x component. To find our y component, what I'm going to do, put this down first. To find the y component, I'm going to take this and substitute it in as x for my function. I'm going to evaluate my function for that value, which I'm not really excited to do, but I'm going to do it anyway. So f of negative 5 fourths is equal to 2 times the quantity, negative 5 fourths squared, plus 5 times the quantity, negative 5 fourths, minus 1. It'd be super great if it's synchronized anytime in the near future. There it goes. That kind of sucks. So what I'm going to go ahead and do, let's see, that's 16th, 25, another 25, minus 16, 66, 33. So negative 33 over 8 is what I get. I believe that is the answer of correctitude. We're going to find out. We're going to see how good my mental math was just there in a second. So in theory, hopefully, my vertex is a negative 5 fourths, negative 33 eighths. You can see why this can be kind of frustrating. We are going to have to estimate that because I am not measuring out eighths and fourths on my little itsy bitsy graph. So let's see, negative 5 fourths, that's 1 1/4, and then about 4. Almost, yeah. All right, so we'll make this the parabola red, and that's like 1 1/4, and like kind of somewhere's around there. Ish. Okay. Now we have to pick some points. Let's see, which point should we do? I'm going to start with 0. 0 seems like an easy point to evaluate. For f of 0, we get negative 1. So I get 0 and negative 1. I like an easy point. Let's see, what else is convenient looking? Maybe negative 2? Negative 2 seems like it should be convenient. ish. Okay, -2, we're going to plop it in. That'll be 2 times -2 squared plus 5 times -2 minus 1, which will give us 2 times 4, so 8, minus 10 minus 1. So 8, 9, 10, 11. Wait, what did I mess up? Yeah, that's right, -3. So -2, 1, 2, -3, 1, 2, 3. We do another one? Maybe, I don't know, -3? Or I think that's enough points to make the parabola. I'm going to do -3. All right, we got 2 times -3 squared plus 5 times -3 minus 1. That would be 9, 18 minus 16, -2. So -1, 2, 3, -1, 2. I think I messed something up there. +2, right? Is that what I messed up? Yeah, that's what I messed up. 1, 2, 3, 1, 2. Draw. 3, 1, 2. There it goes. All right. I'm going to say that's good enough to sketch out my parabola that looks more or less reflected. Then we can graph x minus 3. That one's pretty easy. Get that one in blue. 2, 3 is my x-intercept. 1 over 1, 1 over 1. I should. My graph doesn't look like it touches. I promise it does. Unless I've drawn that fraction in just the wrong spot. They touch right there. So much for my estimating skills. So you see why this can be a pain if you graph it. If your estimations aren't right, it might look wrong. So that means that our solution here, our singular point, is going to be -1, -4. An alternative to doing it by hand like this, where you actually will see it accurately, will be to put it in an Nspire or to put it in Desmos, something like that. But if you don't have access to it, doing it by hand is the best you got. And if you get these weird vertices, sometimes it can be pretty hard to see what your answer is. So this is not my favorite way to do it. The next method, I think is less work, is going to be substitution. So what we're going to do here is, let me see if I can get this where I want it. If that's going to go off the screen. Oh, of course it will. All right, so for substitution, what we're going to do is choose a variable. Choose a variable, any variable. Then we're going to solve for that value in the other equation. Just like when we did substitution of equations. We'll plug our answer back into the other variable, and then we will check our solution. If it's weird. All right, this one, the first example, is super duper convenient. And normally these problems, when you get quadratic, they're going to be in this form where they both equal y. And that's my fave, because we can just set them equal to each other. So I can say x squared plus x minus 1 is equal to -2x plus 3. And now I can just do like old school algebra 1, and I can figure out what's going on. So I'm going to move everything to the left because force of habit. So I'm going to add So 2x to both sides, and I'm going to subtract a 3 from both sides to get x squared plus 3x minus 4 equals 0. I'm going to think to myself, what am I gonna do with this? I need to figure out the solutions. So I would rather factor than put it in the quadratic formula. Let's see, two numbers that make -4 that add to 3, 4 and 1. So x squared minus x plus 4x minus 4. We get x minus 1 plus 4x minus 1, x plus 4, x minus 1. All right, so now that I factored it, my two solutions are going to be -4. Hope I scrolled to the right place. My solutions will be -4 and 1. So x equals -4 and x equals 1. So what I've got to do is plug both of those values back into, honestly, either of those equations. In the name of efficiency, I'm going to choose the simpler equation, the linear one, to figure out what I'm doing. So I'm going to choose, highlight it. I'll choose the y equals -2x plus 3. Plug him in. So y equals -2 times -4 plus 3. So it's going to be, let's see, -2 times -4 is 8 plus 3 is 11. So that point will be -4, 11. And the other one will be y equals -2 times 1 plus 3. And -2 plus 3, excuse me, is 1. So my other point will be 1, 1. And then I'm going to be studious and check that answer on my Desmos. Just because I said I was going to check it. All right, so we had y equals x squared plus x minus 1. And we had y equals -2x plus 3. And our two solutions we said were -4. Did I type something in wrong? X squared plus x minus 1. Oh, yes, I did. That makes way more sense. All right, 1, 1. And my other one is -411, which that's on the other screen. Son of a biscuit. Sounds delicious right now. A biscuit. Sorry, hungry. ADD kicking in there. I'll put on this one. Those of us that are not on the meat. This time I'll type it in right though. Y equals x squared plus x squared plus x minus 1. And then -2x plus. So we have our 1, 1. And our -411. That would have been not super pleasant to graph just because it goes higher than 10, in my opinion. I'll leave that Desmos here because we're going to use it again in a second. All right, so let's give these a whack. Da, 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 da. Where is my mouse? There it is. All right, so let's solve these next ones. So these are both y equal. I'm going to do the same thing, just set them equal to each other. negative 5x equals x squared minus 3x minus 3. I would say to add the 5x to both sides and get 0 equals x squared, is that plus 2x minus 3. Let's think of two numbers that multiply to make negative 3 and add to make 2. We get x squared, let's see, minus x plus 3x minus 3. So we can factor to x minus 1 plus 3 x minus 1, x plus 3 x minus 1, x equals negative 3, and x equals 1. Hope it's okay. I'm going quick through that stuff. I figure we've been there and done that, so no sense in wasting our time on it. What I'm going to do is plug those in. I'm going to choose the first equation because that seems easier, right? That's negative 5 times 3 equals 15. So our first point will be negative 3, 15. And then the other one will be negative 5 times 1. So that'll be negative 5. And our second point will be 1, negative 5. So you see, like I personally think this is way less work than graphing. And then what I will do for those of us that are here, throw this on Desmos so we can see what we're talking about. Negative 5x, and then x squared minus 3x minus 3. And we get 1, negative 5, and we get negative 3, 15. Now, to be fair, if I had Desmos, clearly graphing it would be faster, but if I didn't, then solving it as a system is probably the most efficient way to do it. Do one more of these bad boys. Oh, this one's a bit more of a bummer. We got to think on this one. But 5 minus 3x equals negative 3x squared plus 2x plus 1. So we'll just move over that 5, negative, subtract a 5 from both sides, get rid of the 3, add a 3 to both sides. 0 equals negative 3x squared plus 5x minus 4. Now, this one's kind of a bummer. I'm looking at it, and I'm thinking, I don't know that we can factor this, especially with that negative 3 in the way. So what I'm going to do is quadratic formula it. This should be entertaining. All right. We've got the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a is negative 3. So we get negative 5 plus or minus the square root of 25 No, I wrote that down wrong. This should have been a negative 4. We did not be able to multiply, Mr. Clark. 25 minus, let's see, 16 times 3, 48. Over negative 6. I can stop here. Why can I stop here? Aside from the fact that you can't see it because the board's not synchronizing. Oh, it would make it so much easier if you could see it. Come on, Fourth ISD Network. You can do it. You can do it. Come on, I have faith in you. I couldn't. Oh, no, it just dropped the network. Did y'all's network just drop? No? Just me? Reasons? Let us see if I can't put on my own personal network. We did connecting. All right, come on, do a thing. Come on, do a thing. Come on. Move them electrons. Move them hard. I'm sorry, y'all. One day when we grow up, we'll have internet that stays actually stable. Pretty sure I should like blame construction or something. Yeah, yeah, yeah. Why is this taking so long? Guys, I'm sorry. This is ridiculous. Alright, so as you can see, we can stop now. So I could keep working, but why am I stopping here? I'm saving you heartache. Look at the discriminant. 25 minus 48. That's going to give me, let's see, negative 23, right? Square root of negative 23 is going to give me an imaginary number, which means these graphs don't touch. Like there's no real solutions to this. So I can stop right here. I can stop working. My favorite thing to do. And I can say no solution. If you wanted to keep working it out and do negative 5 plus or minus I squared to 23 over 6, I mean, you could, but I didn't see a reason to. Don't make no sense. Okay, let's see. Wow, it's still going slow. Holy mackerel. No, is exactly what it's telling me right now. There it goes. All right, the next one we're going to talk about is elimination. So I say to use these when they are most convenient. And what I mean by that is both these substitution ones, it was y equals, and they were both y equals, we just put them equal to each other. If they're not both y equals, they can be annoying. So what I like to do, like in this case where it's y equals, actually this one's y equals, anyway, when they're not necessarily convenient, is to use elimination. And the elimination here works the exact same as the elimination that we did with systems of equations. So what I'm going to do is I'm going to look at it and I'm going to see this 3x. I tried to highlight it, which means it'll highlight like tomorrow. I see the two 3x's and I'm going to use those to cancel each other out. There it goes. So what I'm going to do, my top equation, x squared minus 3x minus 2. And I'm just going to multiply my bottom equation by a negative 1. So times negative 1. And then it'll give me 3x and then plus 8. And I can add my two equations together and end up with just an x squared plus 6. Come on, computer. Damn, almost there. Now, x squared plus 6 is a single variable, so I can solve it. I know we didn't talk too much about solving this style, but I think you could probably figure out what to do, which would be subtract the 6 and then take square root. So if I subtract the 6, so this would be equals 0 kind of a thing, I will get x squared equals negative 6. It'd be super awesome if it showed it on the board. OMG. Come on. Come on. You can do it, Johnny 5. All right, same difference. Why can I essentially stop here? I could keep going, and I could get an answer. But I can stop here. I'm going to use my number sense. What's the square root of negative 6? I root 6, right? When we get that imaginary number, there's not a solution to this. We can just say, no solution. I mean, if you want to be fancy and solve it, you could, but I would say just stop here. All right, let's very slowly, I guess. Oh, man. I feel like I should like start writing it and then just say it when it decides to pop up. Do these last two and we'll call it a day. So these ones involve a little other one. Well, one of them does anyway. First one is very similar. So I'm going to look and I'm going to see I've got a pair of 4x's, and I can definitely cancel those out. So I'm going to do the same trick as the last one and multiply my second equation by a -1 so we can get some canceling going on. So x squared plus 4x minus 1. And if I multiply the bottom one times -1, I get negative 4x minus 3. And I can add those two together, and I get, let's see, x squared and a -4. And then I can solve that one. Very slowly. X squared minus 4. So I can solve this. X squared minus 4 equals 0. So I get x squared equals 4. So I get x equals positive or -2. And I'm gonna put that back in my equations. I'm gonna pick the second equation because the second equation is less complicated. So 4 times 2 plus 3, that's 8 plus 3, that's 11. So that point will be 2, 11. And the other point will be 4 times -2 plus 3. So that's -8 plus 3. So that's -5. My second point's -2, -5. Can't believe I just did all of that and it's still awaiting. Ugh. I'm so frustrated by this. I wish I had a better solution for writing on the board. All right, while that decides to do its thing, I'm going to start planning out what I'm going to do for the next problem. I'm looking at it. I don't really have anything that conveniently works for both equations. So I could multiply the bottom one times a -1/2, but then I'll end up with a weird fraction. I don't want to do that. So I think the smarter thing to do would be to multiply the top equation by a -2. That'll get rid of the negative on the x squared, and it'll cancel my x component. I'm going to start writing that, since if I do it now, perhaps by the time class is over, it'll show up on the board. So -2, 6x squared minus 2x plus 8, and then 2x plus 5. What in the world is going on? Watch it all pop up at the same time when it decides to do it.